Today I'm going to look at how you can interact with your Amaze II world via the event system built into it. In the demo you can see that when you impact the carrot, you're awarded 20 energy points, which is displayed, and a sound is generated. Events are mediated by passing a 32-bit word onto an event queue. The event word is made up by ORing the various parameters that you require. Ultimately, there are 3 opportunities for an event to be posted into the queue. These are at the start of the game, when the player descends suddenly, which represents a fall, or when you impact with a face. Both the event word queue and the sound player queue are handled by individual RTOS tasks to make implementation simpler for the world designer. By looking at the event initiated on the beginning of gameplay, we can see how the event code word is put together. We want to start off by setting the energy level to 127 and then displaying this on the screen in the energy bar. We also want to play the startup sound, which is going to be sound number 0. All of these parameters are ORed together to create the first event.event value, and this is then placed on the queue. All subsequent events follow the very same pattern. For a fall event, a reduction in energy is caused by a negative number. A sound is also generated, which is coded to be sound number 2. The third type of event, and in a way the most exciting, is where the event code word is picked from a value found within the array of faces. This event code word is then passed to the queue to generate the various actions. So now we need to see how we can include those event code words into the world so that they can be passed into the queue for sounding or display. In the example world, we have a bouncing yellow beach ball. We're going to add an event code to this so that when you run into it, it adds energy and causes a sound to be displayed. Events are passed from Blender into the world by the name of the material that an object is made out of. This approach means that a world designer can change the value of energy levels, sounds, and actions of other events purely through the Blender interface rather than by needing to get involved with the actual underlying renderer code. The material name is turned into an event by appending _event in uppercase, followed by a hexadecimal 8-digit number, which represents the event code to be passed. If you require faces of different colour to cause the same event, they should have the same event code. Or, of course, you could have different actions related to different materials by altering the event codes related to them. It is important to note, though, that if you want the object to be caused to disappear, the algorithm to remove faces requires all event codes to be absolutely identical. So having entered that dummy hexadecimal value for illustration purposes, let's look at how we can actually generate a useful event code word. As mentioned earlier, I'd like it so that when the player impacts the ball, they are awarded 50 units of energy and sound number 4 will be played. So there are 2 components to this event word. The first one relates to the energy. We want the value to be incremented by 50, indicated by hexadecimal 32, and we want the energy bar to be increased. Secondly, we want to play sound number 4, and that is indicated by the second block. All of these values are ORed together to give us the ultimate event code. This hexadecimal value is incorporated into the event name of the material so that it can be processed and then incorporated into the world correctly. The world needs to be exported from Blender as object files as normal and then processed with JavaScript as described in the previous videos.
Wow!
And now, when we impact the ball, our energy levels are increased and the sound is played. The event system poses a relatively low overhead on the world renderer, and as the events are usually generated when you impact with an object and are therefore stationary, any reduction in frame rate is not especially obvious to the player. I am hoping in the future to develop the event system so it allows deeper interaction with the world. For instance, to start an animation, or perhaps allow interaction with a non-player character. You may wish to code these into the program yourself. Anyway, I hope you have fun building an Amaze II world and incorporating sounds and events into it.